Welcome to homework.
Okay, so for this question, we want to find the finite or infinite intersection and infinite union of different sets. So first thing that we'll do is we'll just look at the finite unions and finite intersections first. So let's just see what happens when we perform it for question A. So A1, if we just look at what A1 is, this is going to be -1, 0, and 1. A2, this will be -2, -1, 0, +1, and 2. And so on and so on until you get a sub n, which is going to be -n plus 1, blah blah blah, -1, 0, 1, blah blah blah, n minus 1 and n. So what we see from this is that a sub 1 is going to be contained in a sub 2, which is contained in a sub 3, which is contained in a sub n. Oh, a sub n. And clearly, if you take the finite union of a sub I, you'll take the last one. So that's a sub n, which is -n plus 1, -1, 0, 1, n minus 1, and n. And then the finite intersection of a sub I is then just going to be the first one, a sub 1, which is just -1, 0, and 1. Now, when we take the limit as n approaches to infinity, so what happens is right here. So then the infinite union of I is equal to 1 of a sub I is then minus infinity, blah, 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 -1, 0, 1, blah, 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 to infinity. So these are just your integers. Now your infinite intersection, if you take the limit as n approaches infinity, there's no n here, so it's just going to be constant, and it's just always going to be -1, 0, 1. Now for B, a sub I is just -1 and 1, or a sub I is -I and I. Then a sub 1 is -1 and 1. A sub 2 is going to be -2 and 2, -2. A sub 3 is -3 and 3, blah, blah, blah. Then a sub n is then going to be -n and n. So if we do the finite union then, I is equal to 1 of a sub I, well, note that all of your elements are different, so it will be -n, minus 1, blah, blah, blah. Then -1, note there's no 0 in this case, so it will be 1 the next time, blah, to n, n minus 1 and n. In the finite intersection, I is equal to 1 of a sub I, you note that there is no similar numbers in between in all the n data sets, or sets, I guess. So it's just going to be the empty set. So then we take the limit as n approaches infinity. So then the infinite union of I is equal to 1 of a sub I will then be minus infinity, blah, 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 -1, 1, blah, to infinity, which is your integers set minus the set of 0, or can be written as minus by set of 0, but the same thing. And then your infinite intersection, I is equal to 1 of a sub I. There is no n here, so taking the limit as n approaches infinity, it will just be the empty set. Now, next question, a sub I is minus I to I. So a sub 1 is then the interval from -1 to 1. A sub 2 is the interval from -2 to 2. A sub 3 is the interval from -3 to 3, blah, blah, blah. A sub n is the interval from -n to n. Now to visualize this, let's draw the line. So if this is 0 right here, then a sub 1, 1 and -1, then this interval right here is a sub 1. Then you have minus 2 to, or 2 to minus 2 to plus 2. This interval is a2. And then it continues on until you have minus n to n, at which point this interval is a sub n, or a sub n. So what you see then is that a sub 1 is contained in a sub 2, which is contained in a sub 3, contained in blah blah blah, contained in a sub n. So therefore the finite union of these sets will just be a larger set, which is a sub n, which is just the interval from minus n to n. The finite intersection will be the smallest one, that's a sub 1. So that's minus 1 to 1. Taking the limit as n approaches to infinity, you have the infinite union, 1 of a sub I, will just be minus infinity to infinity. Infinity. This is just your real numbers. And then the infinite intersection of a sub I is being minus 1 to 1. Now, we have our last one. A sub I is equal to I infinity. So a sub 1 is then 1 to infinity. A sub 2 is then 2 to infinity. A sub 3 is then 3 to infinity. Blah, blah, blah. A sub n is then n to infinity. Now, drawing this once again, you have 1 here. Then a sub 1 is going to be this set. Oh, let's draw that better. It's going to be this set. A sub 1. Then a sub 2 is going to be this set. A2. And an is then going to be this set. So in the exact opposite of what we have last time, it's actually a sub n that's contained in a sub n minus 1, which is contained in a sub 2, which is contained in a sub 1. So as a result, the finite union of I is equal to 1 of a sub I is going to be the largest one of these. So you can clearly see that it will be a sub 1. A sub 1, which is 1 to infinity, and the finite intersection of a sub I is going to be a sub n, because that will be your smallest one, your blue line. So this is n to infinity. Now taking the limit as n approaches to infinity, you have the infinite union of a sub I is then going to be 1 to infinity, because there's no n here. And the infinite intersection of a sub I is then infinity to infinity, which is just nothing.